Hello everyone, welcome to my channel Similarity. In this video we will see how we can create a curling effect for the curves. So let me give you a little demo here. So this is our curve. Let me draw a curve here. And this is how the effect looks like. You can see here. As I move, in my timeline, you can see the curve is getting curled up. Okay. This curling is happening here. Okay. Now let me first remove my keyframes here so that I can give you an overall idea how the controls looks like here. So basically this is the start point and I can control, the point up till which I want this curling thing to happen. Okay. This is what the start point does. And then we have this angle controller here. Basically this controls the total number of spirals we want. Okay. How much, how much curling we want here. Okay. That's what this angle controller do here. Also let me put it here, and this max radius basically controls the maximum radius of this spiral, right? And then we also have this scale here. Basically this is, this is used to controls the amount of scaling on each of these spirals. Basically, you can use this to, create some creative kind of effects if you want, right? You can change the handle types also. Let me change it here to Bezier, and you can see, you can do whatever you want, based on your creativity. And then also we have this reverse short option. Basically this is used to change the direction from which the curling begins. See here, I have changed the direction here. This is not looking good here because there's other setting also that I have to change, but you get the idea, right? So so this is how this effect actually works. And so before I begin creating this from the scratch, let me give you an overall idea of the whole code here that I've used to create this effect, so that you have a picture, an overall picture in your mind, before before we start diving into the whole thing. Okay. So let me put this here, and also set my max radius to something like this. I think it looks good. Okay. And also before I begin, let me show you one more thing. I forgot, sorry. You see, initially our effect looks like when I move this timeline here, it feels like this is kind of curling, right? The loops are increasing as I move in the timeline. So let me tell you, give you the example how I did this. Basically I use a little expression here. First I create a keyframe here, and then I created a keyframe here. Okay. Now for the curling to increase, basically I used a little expression here, dollar $ff upon dollar $f end multiply 10,000. Okay. Now if I move it, you can see also here. You can see as our curl moves along the curve, the amount of loops are also increasing. Okay. Okay, so this is how it works. Also now let me give you an oral idea how this whole code works. Okay. So first thing, let me remove this and this. Okay. Okay, so the first thing I did here, basically I created a curve here, right, using the draw curve node. And then I resampled the number of points here. So let me reduce it so that you can see it clearly. Okay, so now we have basically 87 points total. And then I use the short node, and I already told you I use the short nodes to change the direction of the curling effect. And then we have the polyframe node. Basically this node provides us three different vectors this normal tangent u and tangent v, and I use these vectors to basically get the center point for the curling effect. Okay, and what I mean by that, let me show you here in the Photoshop. So as our Photoshop is opening, let me tell you other things as well. So you can see here, after I created the polyframe node, I get these three vectors: tangent u, tangent v, and normal. And then inside here, attribute triangle, I basically use these three vectors to get the location of the center point, and also I have a start point also. So I think our Photoshop is opened. Okay, let me show you what this center point and start point is. So let's say let me draw a line here. So this is our line. Consider this is our curve. Okay, and these are the points in the curve. Then basically, let's say this is our start point. Okay, consider this point as our start point. Let's call it S. So basically, start point is the point up till which we want the curl to happen. See, after this point, these point will be, they don't have any kind of curling. Up till this point, the curling will happen. Then just above this point, we have a center point as well. Okay, so our curl will look something like this. Okay, so we have 2 points here: center point and a start point. Okay, a start point is the point up till which the curling happens, and center point is the point just above the start point, and this is used for as a pivot for the curling effect. Okay, so that's what I did here, and for the center point I use the polyframe node using this tangent v vector. And then I've created a gradient. Basically this gradient goes from center point to the last point. Okay, so for the center from the start point to the last point. So for the start point, gradient value is 0, and for the last point the gradient value is 1, and point before that also has a gradient value of 0. Why I did this? Because the points which are further away has to rotate the most. These points are rotated the maximum amount, and the point which is very closer to the start point has a zero what to say, like, has a very less rotation. Okay, so the rotation amount gradually changes from the start point, which is minimum, to the last point of the curve, which has the maximum amount of rotation. See, that's why we get this curling kind of effect. Okay, and then after the gradient I have created this setup here, this code here. Basically this code converges all the points after the center point, after the start point, to the start point. Okay, what I mean by that, see, all the points, these points after the start point will converge to the start point. Okay, these all will uh, change their position, and they'll lie on top of this start point here. They merges here. Okay, why I did this? Because if I don't do it, our curl will look something like this here. It won't look like this here. Okay, that's why I did this. Don't worry, you will understand everything once we create this whole thing from the scratch, but I'm just giving an overall idea how the thing works. And then finally, after getting all the center point, start point, and gradient, I have used matrix here to perform the rotation and scaling for the curling effect. Okay, and then finally I have blasted the center point also. But before let me show you the center point here. Let me turn this off. You can see this point here. This is the this is the center point, right? Around this point our curling is happening, and this point number 86 right now is the start point. See, that's why we are not seeing any curling effect, because the curling is happens for the points which lies after the start point, right? After the start point. So let me show you here. Let me move this something here, and also let me change the angle here. Yeah, so you can see right now this point is the start point, and just above this point, this point is the center point. Okay, so let me show you here one thing. You can see we have, there's a point beneath this point number 87. Basically, that's the center point, and that's what I deleted here because we don't want that. Okay, that's why I did this. Okay, so this is how this whole code works, and this is an oral idea. So if you don't understand any, just keep patience because this is just to give you an overall picture of the whole thing. Okay, okay. So now let's begin creating this from the scratch. Okay. Okay, so let's begin by creating a draw curve node here. Let me change my view to top view and projection plane to ZX. Okay, so let's draw the curve here. So this is my curve, and right now you can see the distance between the points are not very even, so we can resample this. Okay, so now the points are at very even distance. So the next thing that we need is a polyframe node. And let me check this tangent v vector here. So you can see this node gives us these three vectors. This blue one is the normal vector, red one is the tangent vector, tangent u vector, and yellow one is the tangent v vector. Okay, and these three vectors are orthogonal. Let me make this orthogonal here. Okay, so what that means? Basically, this means that these three vectors are perpendicular to each other, right? That's what we get here. Okay, so why we plug this polyframe? Why we need these three vectors? Because we need to basically create 2 points here, right? A start point and a center point. Let me tell you what these points are. Okay, I think this is from the previous video. Let me remove this. Okay, so let's say this is our curve here, right? And these are the points on the curve. And let's say first what I have to do, I have to select a start point on the curve. Okay, so let's call this point as a start point. So what this start point is, basically start point is the point up till which we want the curling to happen. Okay, so all the points after this start point will curl, and the point before the start point won't curl. Okay, and just above this start point we also have a center point. Okay, this point here is the center point. We will use this center point as a pivot for the curling effect. Okay, so our curve will look something like this here, right? So this point in the middle is the center point and this is the start point, and center point lies just above the start point. Okay, and that's why we are using the tangent v vector here, because as you can see here, this yellow line, this is the a tangent v vector. No, this points in the direction of tangent v vector, and as you can see, for any of the point, let's say for this point, this vector points directly just above it. Okay, so we can use this vector to create the center point. Okay, so let's begin creating it. So for that we will create a attribute wrangle here. Let's call it center point, oblique underscore start point, start pt. Okay, so that we know that what we are doing here. So for that, the first thing we need to do is to get the total number of points in the geometry. But before that, let me run it over the detail, because we don't want to loop or any kind of data or anything like that. So it makes the whole code a light, very light, and increase the performance overall. Okay, let's run over the details here. So first we need to get the total number of points in the curve here. For that we use the endpoints function. Basically this functions gives us total number of points in the geometry, and let me do the -1 here. Why I'm doing this? Because as you can see here, the point count start from the point number 0. Okay, that's why the point count start from the point number 0, but we want the we want the exact point number of the point. Okay, that's why I'm doing the -1 here. And next thing, I create a variable called the start point. Start pt equals, okay. I'll explain what I'm doing here, but just first let me write the code here, then I'll explain everything. Okay, let me write the code here. It ch start pt, and this value goes from 0 to 1, and in returns it gives us the value which goes from 0 to npts, number of points. Okay, so let me tell you, let me explain you what this thing is doing here. Okay, so what I'm doing here basically, this start point parameter, this parameter here, okay, this goes from 0 to 1, right? And in returns this gives us, this function gives us the value which goes from 0 to the from 0 to the last point number, which is 197. Okay, this is what this whole thing is doing here, right? Also you can see right now basically, you know, this function alone gives us the value in decimal form. Okay, so for that first we need to convert this into integer, you know, for the proper, you know, what is it, like, for a clean code. Because if I, you know, let me show you over here, I at the rate start pt equal to start pt, you can see the value here is, see, the value here is actually integer, because you know we are doing the conversion here itself. But see, I believe this is not the, you know, correct way to write a very clean code. So see, I always prefer to write a very clear and understandable code, so that you know, you won't get any kind of error, you know, afterward. So for that, first I use the trunc function. Basically this function removes the decimal part of the number. So let's say if I get the value of like 1.56, see, this trunc function only gives us the value 1, it removes the decimal part. Okay, then next thing I do is convert it into integer. I think this is the very correct way to write a very clean code, but it just depends on you how you want to write. But this is how I write code. I don't want to get any kind of error afterward. Okay, now you can see I am getting, as I move from 0 to 1, I get the value from 0 to 197 here. Okay, so what we did here, we get the location of the start point. Okay, now next thing we have to do is to get the location of the center point. So for that, first we need to create a radius attribute, because we want to know how far this center point is from the start point. Okay, radius. Okay, max radius. Let's call it max radius. Then next thing, we need to create a radius vector. Basically this vector gives us the direction along which this center point lies. Okay, and we already know this, that vector will be the tangent v vector. Okay, so let's call this radius vector, and point 0 tangent v start pt. Also let me normalize this as well. I'm normalizing it because, you know, I don't want to get any kind of magnitude from this. I want a unit vector. See, I'm using this vector just for the purpose of directions. Okay, and okay, I think, yeah, this will work. Also one more thing you can do here. See, sometimes this point function get really confused, see, about what kind of value it is returning. So we have to, you know, point it out that you are returning the vector attribute here, or a vector value. See, that's why I'm enclosing it inside the vector here. Okay, so that it knows the value that we get from this is a vector. Okay, so we got the radius vector here and also a radius value here. Now let's create a center point. Don't worry. Once I write the code here, I'll explain everything. Just bear with me for some time. Okay, so let me explain. Okay, so what I did here basically, first, up till here, basically, first I got the location of the start point. Okay, so let's say this is my start point, this point here. Then from this point, I have added this radius vector here, which points in this direction. Okay, and also I am using this radius parameter as an, what to say, like as a magnitude, or as a what to say, like the value of the radius here. Okay, and see, that's how we get this center point here. I will use the add point function to basically add a center point here. And as I move this, you can see this center point moves along the curve here. And as I reduce this parameter here, you can increase the radius or decrease the radius of the for the center point. It's, or you can say it's distance from the start point. Okay, that's how we can control it, right? Now next thing that I need to do is to get some parameters or values from this code here. So the first thing we need is the total number of points. I am doing this because we will be using this later in the code, so I am putting it inside attributes so that we can use it later. I at the rate total points. Total points will be npts, total number of points in the curve, minus the start point, and then plus 1. So what this basically is, this is the total number of points after the start point. Okay, and also we are counting the start point also. Okay, in this here. So what I mean by this, let me show you here. So basically, let's say this is our start point here, okay, right? And these are the points after that. So total point gives us the total number of points from the start point to the end of the curve. Okay, so this basically gives us 1, 2, 3, 4, and 5 points. Okay, this is what we get. See, we are not counting the points before the start point. Okay, in this attribute here, right? Total points. Also, I can write it here as well so that you can remember it. See, npts is the total points in the curve. Okay. And this total points is the total number of points after the start point, or you can say from the start point in the curve. Okay. So that's what we are getting here. Next thing we need to do, also we can, I think, store the value of start point and center point as well in an attribute. So start pt is equal to start pt v at the rate center pt equals center pt. Okay. So we got all this. See, we have the total number of points, we have the radius, and also we have the points, total number of points after from the start point, and we also have the location of the start point as well. See, these are the attributes we will be using later in the code. Okay. Okay, so the next thing that we need to create here is a gradient attribute, and the value of gradient goes from 0 to to this last point here. Okay, it gradually changes from 0 1 2 3 4 5 6 till the last point number. Okay, and points before that has a value of 0 for the gradient. Okay, point which which lies before the start point, right? So let me create a attribute wrangle here, and we can call it grade or gradient, and we can also run this for details, because all the this attribute here we are we are having at the detail level, so that we can get it very easily here. So we'll use a for loop. We are using the total points here because we want this loop to run for the total number of points which are lying after the start point. Okay, so we use I plus plus, and then we can set this attribute on the point label, set point attribute 0, or we can call it grad, and next we have to give the point number for which we want to set the value. So which that will be our start point, start pt plus I. Okay, because we want to set the value starting beginning from the start point and then for the point afterward, and this is the value that we want to set. Okay, and we can check this also if you want. Okay, this is our grade attribute. Let me turn off the point number here, and you can see let me change this to our top viewport. Okay, so you can see this is our start point. Okay, this here, and this is our center point, and you can see the points after the start point has a gradual change in the gradient value. See, 1 2 3 4 5 6 till point number 27, and the points which are before the start point has a gradient value of 0. Okay, and we can change this also here. Let me show you. So you can see as I move the start point, the point before that has a gradient value of 0, and point after that will have a gradual change in the gradient value. Okay, so why I've created this gradient? Because see, the point which is further away from the start point will have the max rotation amount, and the point which is very closer to the start point will have the least rotation amount. Okay, and I will use this value for that to gradually change the amount of rotation for each of these points, right? Okay, so the next thing that I need to do right now is to, move all those points after the start point to the location of the start point. Okay, basically what I'm trying to say is, converge all those points to the start point here, or move all those points, to the location of the start point. Why I'm doing this? Because right now, if I don't do this, the curl will look something like this, right? So that's why I'm converging, all the point afterward to the location of the start point, right? Don't worry, you will see this, effect once we run the code, and I will show you why we are converging the point. But that's what we have to do next year, okay? But I won't be showing you this in this video because this video is already running from a very long time, and I also want to get some rest here. So the next part will be the final part, and we will cover all the rest of the code in that video. Also, this is also kind of homework to you. To if you want, you can create the rest of the code yourself. You already know the logic, and also I will be providing you the file for this whole project. It's available in my Gumroad page, and the link is available in the description here. So if you want, you can create it by yourself, the rest of the code, and you can recheck from the file if you want. Okay, so this is it for this video. Thank you for watching it, and see you in the next video. Bye.